Okay, so we're going to take a look at perimeter, area, and volume of a parallelogram. So here we are, perimeter. This stuff I think you're going to like. If you understand perimeter, area, and volume of a rectangle, you're going to like this because it's the exact same formula. The reason why is, have you guys ever seen, maybe this doesn't happen in your house, in my house, a lot of stuff breaks all the time. So it's like you have a bookcase and all of a sudden it's like kind of over on an angle and it's still, the corners are still connected, but it's kind of tilting over. Think of that. It's like furniture that's kind of falling apart, right? Or like IKEA furniture before it's like all drilled in nicely. It's just not totally straight, not totally a square yet, not a rectangle yet. So either breaking, not quite there yet. Parallelogram. So as a result though, like again, imagine a bookcase that's kind of tilting over. Its original shape is actually still a rectangle. So in this case, perimeter, just like a square or rectangle, is you add up, it's like the distance around, like as though you're building a fence or baseboards or crown molding or something. It's just the walls that you're interested in. Yeah, that's perimeter. And so again, we go A plus A plus B plus B. It doesn't matter which one is A, it doesn't matter which one is B, you simply add them all together. So in this case, if it was like A plus B plus B, then you're going to have, and again, I'm just randomly going to say A is 3, okay? 3 plus 3 plus 2 plus 2. It doesn't matter which one is A, which one is B. So 3 plus 3 is 6. 2 plus 2 is 4. So 6 plus 4 is 10. So my perimeter of this parallelogram, I just go 1, 2, 3, 4, and I add them up, and there's my perimeter. One of the things you guys might find, which would be frustrating, and it would be frustrating for me because I don't like things that are not explicitly clear, is let's say your parallelogram looks like this and your teacher's only giving you 2 numbers. What you got to do is try and look at this shape and be like, okay, well, what wall looks like this wall? Is it closer in length to this one, or is it closer in length to this one? Well, the opposite walls, the opposite sides are going to be the same value. So the top and the bottom one are going to be the same, and the left and the right are going to be the same. So even if, let's say, you don't have any numbers here, you're not just going to be like, well, I'm only going to add up the 2 and the 3 and then I'm done because that's all I've been given. You actually have to add up the 3 and the 2, and then the 3 that's not written down, and the 2 that's not written down. So in this case, it's actually still A plus B plus B. So let's say in this time I'm going to start with 2. 2 plus 2 plus 3 plus 3. Well, 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 6 is 10. So perimeter of a parallelogram is the same as perimeter of a rectangle or a square. Let's move on to area. Area is the space in between. It's all of this. Think surface space, okay? Let's say you're making a painting and you need to know how much paint you have that it's going to cover your canvas. Surface area. So our formula is still A times B. Even though it's on a slant, even though it looks tilted and it's like, that's not a rectangle, I don't know what to do. Nothing changes, formula still A times B. And you don't have to think like, oh no, which one is A, which one is B? It doesn't matter because they're the same. So A times B is the same as B times A. So A times B, let's say I went 2 times 3. And again, I don't know more than you do about this question. I'm not like, yeah, 2, that's definitely an A. 2 could be A, 2 could be B. It does not matter. Okay, B times A. So let's say in this time, B is going to be 2 times 3, right? 2 times 3 is 6. 2 times 3 is 6. It doesn't matter which one I call which one. I just take one number on one side and I multiply it by the number on the other side. And that is my area of my parallelogram. Let's look at volume. So I really tried to make a really nice parallelogram drawing and it's very challenging. Let me just color in the back wall a little bit so you can see that hopefully it looks like a parallelogram and not just like a very action-oriented rectangle boosting off into space. We should actually be given art lessons as teachers, how to draw a parallelogram. So let's say in this case, again, I'm still dealing with the 2 and the 3. Like I had here, like on my base, it was 2 and 3 on the base, but now I'm adding in the dimension of height. So imagine like an accordion that's just going, and it's just expanding, okay? So my expansion, my height is number 4. So let's pretend that the base is 2 times 3, and now the height for maybe it's a room or a box is 4. So my formula for finding the volume of a parallelogram is actually still, just like a rectangle, A times B times C. So, and it does not matter if I call this side A or this side B or this side C. It really doesn't matter. So I'm just going to go 2 times 3 times 4 equals, and just like a rectangle and a square, I could go 4 times 3 times 2, or 2 times 4 times 3, 4 times 3 times 2, 4 times 2 times 3. It doesn't matter the order. It's going to be the same. Let me show you twice, okay? So 2 times 3 is 6 times 4. 6 times 4 is 24. Maybe I did the order where it was like 4 times 2 times 3. Well, 4 times 2 is 8, times 3 is 24. So as long as you're taking one number from each side, don't, like, sometimes people will say like it's length times height times width. Doesn't matter what you call it. In order to figure out the volume of something, you have to account for one of each side of something. So if I have nothing in my room right now. It looks like a box. I can't show you anything. So if I had, like, pause there. I'm going to get you a Kleenex box. I'm back with my Kleenex box, my little demo. Let me show you what I mean by this. Let's say I've got a box, Scotties, and I'm holding it like this. You're going to be like, okay, the width is this way, because the width is like, if you look at how wide something is, you're looking at somebody, it's like, how left and right is it? The height is up and down. The depth is back this way, okay? But watch, if I go like this, woo, now this is the width. This is the height. This is the depth in here. Woo, now I go like this. Now this is the width. Now this is the height. And this is the depth. So I wouldn't worry too much about what you call it, because at the end of the day, this box, if I hold it like this, or like this, or like this, it's still going to hold the same amount of tissue. Doesn't matter how I hold it. Like, it's not going to be a bigger box because I hold it like this or because I hold it like this. So with volume, when you're looking at what is, length times height times width, or what is A times B times C, don't worry about that. As long as you have, and you're trying to figure out volume, like if I'm like, okay, my box goes this way, I'm going to measure this side. It's got an up and down side, so I'm going to measure up and down. I can measure this up and down angle, corner. I can measure this one. I can measure this one. I can measure this one. It doesn't matter. As long as I have an up and down accounted for, a left and right accounted for, and a back and forth accounted for, then I can measure my volume. So there we are, just A times B times C, one side times another side times another side. And there's our answer, even if it's a parallelogram, even if it's like squished, a rectangle that doesn't look like a rectangle, parallelogram. So same formula as a rectangle, even though it's just kind of tilted a bit. All right, good luck.